Hi, hello. Welcome back to Gillesania Engineering Videos, your daily supply of solutions to engineering problems. Again, if you like what you see here, please don't forget to subscribe and hit the bell icon so that you'll be notified every time we have new videos. Okay, in this video, I will be continuing with friction and this is now part 3. So, I hope you watch the first part and the second part for you to be able to catch up with this topic. So, here we'll be solving another sample problem. Alright, so here we have compute the maximum angle of inclination theta of the ram without causing the block to slide. The maximum angle theta. So, if you recall, there are two types of problem in friction. We have one is the very common one is the I could say the impending motion state, wherein the friction that you'll be using is the maximum available friction, which is equal to mu n under static condition, of course. And the other one is maybe not impending, a little bit lesser than mu n, and that will require that will be inequality, of course. Okay, and you can sense the problem if it is impending or not. As in this problem, that's very clear, without causing the block to slide, the maximum. Well, obviously, if you use your imagination, the more angle you give to this ram, the more likely the block will slide. So, what will be the smallest angle that will the maximum angle of inclination without causing this block to slide? Actually, if you know that the answer here is very clear, if you know the principle, you can answer this immediately. But I'm going to present to you the principle here. So what are the forces acting? First, the forces acting here, we have the weight of the block. We don't have that weight W, and then we have the normal reaction N, and the frictional force. Obviously, this block will go to the will go down, so the friction force will go up. So we will use here the maximum available friction. Alright, only three forces are involved. You can use force polygon, or you can use summation of forces x and y. For convenience, we can rotate the axis, the x-axis parallel to the plane, the y-axis perpendicular to the plane. Well, this angle here, this angle is equal to theta also. Then we have here F max now along x and along y, and W at an angle with the coordinate axis. So let's solve first for n. Summation of forces along y equals 0. Then you have n is equal to W cosine of theta. Then summation of forces along x0. Then you will have F max is equal to W times sine of theta. Okay? So F max is equal to mu n. So we will be using the maximum available. So mu Sn is equal to W sine of theta. And since we already know the value of n from this first equation here, then that will be substituting that value of n. Alright, and we can cancel this W, we can cancel that out, so that if you cross multiply that, this will become sine over cosine, or tangent of theta is equal to mu s, or theta is equal to arctangent of 0.3, or that is 16.7. So if you notice, this is the angle of friction. Tangent of theta is mu s, that is PS, arctangent of mu s, angle of friction. So what I'm trying to explain here is that the maximum angle that this incline, the block or the ram can be inclined without causing the block to slide is the angle of friction. So you can imagine this. If you want to know the angle of friction between two contacting surfaces, you can incline the surface, and at the moment that the body will slide past that surface, okay, just do it slowly. So the angle that the block will slide, that's the angle, or the body that the block will start to slide, that is the angle of friction. And this is a very important value for us to know whether the block, a problem with this kind of inclination, the block will slide or not. Okay? Now let's have another example here. By the way, these are the principles. The total reaction here will be perpendicular. Vertical, sorry. Will be vertical. Now let's have another example. Very similar block. Okay, I just put here the weight. Okay, determine the horizontal force P required to hold. Take note, to hold the 100 kilogram block shown. Let me add on this. Excuse. Okay, the minimum horizontal force P required to hold the block shown. To hold meaning, because, okay, what will happen if you will release this force? Will the block move or not? Okay, how will we assess? Okay, look here. The angle of inclination is 30 degrees. And the coefficient of friction is 0.4. So as per the previous problem we had, if we compute the angle of friction is arctangent of mu s. Okay? So that will be arctangent of 0.4 is 21.8 degrees. So meaning the maximum angle that this plane can be inclined without causing this block to slide alone without the force P is 21.8. So if the angle becomes more than that, here it is 30 degrees, then it will slide. That is why we need to hold the block. And that is the question here. The smallest force P required to hold the block in place. So to prevent it from sliding. Alright. Okay, so knowing that, let's identify the forces. We have the weight of the block, 100 times G. So that's 981 newtons. The normal reaction, N. Okay, so, and the friction force. So where will be how will the friction force be directed? Is it going down? The friction force, is it going down or going up? Is it going down or going up? Now, many students would say going down because it is opposite to P. Okay, many would think that way. Okay, take note that friction is not opposite to the force. Okay, friction is opposite to the motion or to the tendency to move. So you have to identify what is the tendency of motion. Now, the problem here is we are going to hold, and in fact, the minimum, the smallest force that will hold the block. So meaning we are just preventing, we are not pushing the block up, we are just preventing it from sliding down. So meaning the tendency of motion is down, so that the friction should be up. The friction should be up. So again, you have to identify the direction of motion and oppose that motion. So, and this will be impending motion. So we will be using the maximum available friction. Maximum friction. Alright? So again, just like in the previous problem, let us rotate the axis, x parallel to the plane and y perpendicular to the plane. Okay, so this angle here is theta. Okay, that angle. And this angle also is theta. Let's solve the normal. It will now be as a function of P. The measure of forces along y equals 0. Then we have going along y is n. Okay, equals W going down. Going down will be 981 cosine of theta. 30 degrees, theta is 30 degrees. And P sine of theta, the component of P. Alright, so we have here the value of n in terms of P. Then, summation of forces along x equals 0. X is parallel to the plane. So, forces going up along x will be P or F max plus P cosine theta ito. Plus P cosine theta minus weight sine of theta equals 0. Alright, and what is F max? F max is mu times n, and this is your n. let's substitute that. Mu times n. Okay, plus cosine 30 degrees is 0.866 minus 981, sine of 30 is 0.5 equals 0. So here we can solve the value of P. That is 141.34 newtons. 141.34 newtons. Right? So if we will get the total reaction or draw the total reaction, it will be like this. This is our angle of friction here. And this is our total reaction. Okay? So we have an alternate solution to this. We have an alternate solution, but before I go to that, let me invite you to join our YouTube membership, our GERTC Lite and GERTC Plus. So what is GERTC Lite? So GERTC Lite, you can if you will join this at 499 pesos monthly subscription only, you will have access to all our recorded review lectures last June 2020. All our lectures, all the subjects. Okay, all the subjects, so that will be over 160 hours of exclusive content, 70 CE lectures, all the achievement tests, and you will have early access to all our coming YouTube videos. Okay, for the Plus, there will be additional features for our GRTC Plus. So you will have access to all our growing library of videos, specifically the recent board exam. And you will have discount in all our books. 50% discount and 15%. And on your first book, 50% discount. So now, once you have joined our YouTube Lite or the Plus, you will have access. Now, if you click on this link, by the way, you can visit our grtchub.com, our website. If you click on this, okay, you will have all these courses. You can choose the topic you want. For example, if I want strength of materials and I like to study about, for example, voltage connection, it will lead you directly to that video.
Basic strength of materials.
Okay? And if you want to study about, okay, let's continue here. If you want to study about analytic geometry, yeah, analytic geometry. And a particular topic in analytic geometry like circle, if you click on that circle, it will lead you to that video. Very comfortable, very easy to use. Alright? So, monthly subscription, you can subscribe for 1 month only, or you can have it, if you want, after a month, you cut your subscription, so you will not renew, and then you will renew that again after several days. It's up to you. Right? So, yeah, just inviting you. So, this is good for, ideal for undergraduates, for those who are preparing for the board exam, okay, working students, those who are from abroad, okay, and if you are reviewing from other review centers and you feel that you are behind already, then this is advisable for you. Right? GRTC Lite, 499 pesos per month, and GRTC Plus at 899 pesos monthly subscription. Okay, let's move on. Let's have an alternate solution. Alternate solution to this. So here we use the analytical solutions, summation process X and Y. But normally, problems in friction, especially blocks like this, can be solved easily using the force polygon. Most of you knows that method already, no? The force polygon. Notice that there are 4 forces here, P, W, and N and F. But since N and F can be resolved into its resultant, then we will be dealing here with 3 forces only. The W, the R, and the P. And for these concurrent forces to be in equilibrium, they have to form a closed polygon. And a polygon with 3 sides is a triangle. And this is a very easy triangle because W and P are perpendicular. So look at this. Alright. Okay, again. So applying that head-to-tail connection, we have our P, our R, and our W. The weight here is known. The weight is known, and that angle of R from the vertical is, if we can solve that angle, let's call that beta. Then, and since the weight is given, and this is a right triangle here, we can easily solve the value of P. So what is the value of beta? So that's the angle of R from the vertical. That's it. This is our beta here. So this angle here is your 30 degrees, theta. This is the angle of friction. The angle of friction is always from the normal to the reaction. So this is the angle beta, the angle of R from the vertical. And from this figure, beta is equal to 30 degrees minus PS. 30 degrees minus 21.8. So that's 8.2 degrees. So we have now the value of angle beta. So finally, from this right triangle here, tangent of beta is P over W. So we can solve the value of P, and that will give you 141.36, the same value here. Okay? So that would be faster. Alright. So let's have one more example. Okay, this is the part 3. I will have part 4 of this pa, ha? Okay, let's have another example. By the way, in this problem, we are just required the minimum. By the way, that's the minimum force to hold the block. So what if the force here, the force we apply is only 140? Well, theoretically, if that is the case, the block will slide. No? The block will slide. If that force is less than 141. If the force will be more than that, let's say 145, well, I cannot say it will move up. But for sure, it will not slide down. It may not move up yet. Okay? Let's try that. Let's have another example that will answer that question. So in this problem, the minimum then, determine the minimum horizontal force P okay, the minimum horizontal force P required to move the 100 kilogram block up the plane. So very particular, up the plane. So unlike in the previous problem, we are just holding the block, preventing it from sliding down. This time we will push the block to move it up the plane. Yes. Alright, again, the angle of friction is arc tangent of 0.4, just like in the previous problem. That is 21.8 degrees. Okay, angle of friction. So to solve this fast, I will be using the alternate solution. We will be using the force polygon. So the forces here, we have the weight of the block, the normal reaction here, and the frictional force. Okay, in this case, since we are going to push the block, so the tendency of motion is up, so the friction must be directed downward. Alright, directed downward. So this is your F max. So we will be using the impending motion state, the maximum available friction. So therefore, the resultant of F and N will be like this. And that will be your R. The resultant reaction here. Okay? So, the reaction is R. So, drawing the force polygon, we have W, P, and R. We have here the W, 981. And we have the P, unknown, and the R. The R. Right? So, we need the angle. If we can solve this angle here, then we can solve the value of P. Take note, W is given. So what is that angle? Let us call that beta. So here, that angle beta is this one. This is our beta. Okay? So again, the angle of R from the normal, this is your angle of friction, which is 21.8. And the normal from the vertical, obviously, is your angle of inclination, theta, which is 30 degrees. So here, beta therefore is equal to theta plus phi. So that will be 51.8. If you remembered in the previous problem, beta is theta minus phi. So here it will be bigger, 51.8. So knowing now the value of beta, then your P is equal to W tangent of beta. So W tangent of beta, that will give you 1246.63. Okay. So that's it. That's it. I hope you learned a lot from this lecture video presentation. We will have part 4 later. Okay, we still have our part 4 for friction. So these lectures are very enough for you to prepare for the board exam. These are the common questions in the board exam. So in the next part, I will be solving the recent board exam questions regarding or dealing with friction. Okay? So thank you so much for watching.